Alright students, it's week number 12 and session number 56, and the exercise we were doing in the last class is 20.2, and in today's session we are going to continue with the same exercise, right? Now in last class we had discussed about the basic integration, the difference of definite and indefinite integrals, and how to solve integration, the strategy to solve integration. We had discussed all the things. Now in this session, that is quite important, in this session we are going to discuss about reverse of differentiation, and that is basically equals to integration. Now if I recall that in last class I had told you that in differentiation, when two functions are multiplying, so we discussed about u into v, and when two functions divide, then we discussed about u upon v, right? But you know that in integration there are no such rules like u upon v and u into v. So when you have a function like this, now if you see this question, it's question number 10 from the exercise 20.2. if you observe this question, so there are two functions that are dividing, right? So how we can solve the division of two functions without the knowledge of u upon v in integration? So in such type of questions we recall this concept, that differentiation it is a reverse of integration, or integration is reverse of differentiation. Now in the question it says that show that dy dx of x times root x plus 1 is equals to 3x plus 2 divided by 2 root x plus 1, and then it says hence evaluate. It means that we are going to use the answer of this part to solve this question here. Alright, so what we need to start from, it says show that means we need to prove that this expression, when we derivate it, it is equals to this one. So first we are going to differentiate this function. It's x times under root x plus 1. In terms of power, I can say that it's x times x plus 1 with the power 1 upon 2. Since there are two functions that are multiplying and we need to solve for differentiation, so first we need to assign u and v here. So u is equals to x and v is equals to x plus 1 to the power 1 upon 2. So first you need to give it a try by yourself, derivate the function and prove that it is equals to this one, and for this part you have a time of 2 minutes, so start. Alright, so the formula we have is u derivative of v plus v derivative of u. U is x, the derivative of v is equals to 1 upon 2 times x plus 1 with the power minus 1 upon 2, right? So it's x v dash is 1 upon 2 x plus 1 with the power minus 1 upon 2, plus v is what? X plus 1 1 upon 2, and derivative of u is x. Alright, we have substitute the values in u into v, and after that it's negative power, so we can shift the negative power into denominator, so it will change its sign, so that will be x plus 1, alright, plus x plus 1 with the power 1 upon 2 times x. Alright, now if we take LCM here, so that will be equals to 2 times under root x plus 1, that is the LCM, right? And in the numerator it will be x plus 2x, and x plus 1 to the power 1 upon 2, it will be x plus 1 only. Alright, and there is one mistake, that the derivative of u is 1, so instead of x it's 1 here. Alright, it's 1, so that will be only x, and after that it will be x plus 2x plus, it will be 2 only, right? Alright, so x plus 2x plus 2 divided by 2 under root x plus 1, So x plus 2x, it's 3x plus 2 divided by 2 under root x plus 1. So we need to show that same. Alright. So we have proved the differentiation part. And now for the next part, in which we need to find out the integral. Now listen to me carefully. What we are saying, that we have a function d by dx of x under root x plus 1. So when we derivate this function, its answer is equals to 3x plus 2 divided by 2 under root of x plus 1. Right? Very simple. When you derivate this function, the answer is this one. Now we know that differentiation and integration are reverse to each other. It means that if I integrate this function, so I can say that integral of 3x plus 2 divided by 2 under root of x plus 1. On the left side, differentiation and integration cancel each other. The leftover part is x times under root x plus 1. So the integral of this function is equals to this one, right? It's very simple. If you apply integral on both sides, integral and derivative cancel each other. So you got the integral of this function with the help of your differentiation, and that is why we refer this topic is reverse of differentiation is equals to integration, or reverse of integration equals to differentiation, right? So in order to find the integral of this part, we cannot do it directly, and to find the integral, that is why this question was given prior to it. So first you need to solve this function, and once you got the expression this one, then you can apply the integration on both sides. You got the integral of this part. Alright. Now the next problem here, we have 2, and in this question there is no 2. So you need to eliminate 2 from this part, and 2 is a constant, so we can shift it. So integral of 3x plus 2 divided by under root of x plus 1. 2 is multiplying. When you shift, it will be 2 is dividing here. When you shift, it will be multiply, and the expression we have, it's x time under root x plus 1, and we have the limits assigned in the question. It's 3 and 8. Now we know very well how to solve limits. The working principle is we need to assign upper limit, and that is 8. So it's 8 under root 8 plus 1. Upper limit minus lower limit is 3. 3 under root 3 plus 1. Alright, further it will be 2. 8 plus 1 is 9, and root of 9 is 3, minus 3 plus 1 4, and root of 4 is 2. So 8 3s are 24, minus 3 2s are 6. So 24 minus 6 leads to 18, and 18 2s are 36. That is your answer. Alright, so that is the first question of the concept reverse of integration, and the principle is quite same, that first we need to derivate the function, and you need to use that answer to find out the integral. You need to make sure that these two expressions must be same. That is why we have eliminated 2 from the right side, because we need to find 3x plus 2 divided by root x plus 1. So you can shift the constant easily. Alright. So now you need to write down the solution in your copy, and for that part you have a time of 90 seconds. So start. Alright, done. So moving on towards the next question with the same approach of reverse differentiation. It says that show that d by dx of x divided by 1 plus 2x equals to 1 divided by 1 plus 2x whole square. Now first I will attempt this whole question by myself, and then I'll ask you to write down the solution, and for that part I'll give you sufficient amount of time. So you need to listen to me very carefully, and no need to write down the solution while I am explaining the question. Alright. So firstly I need to derivate the function, and there are two functions x and 1 plus 2x. So for that part I need to apply u upon v here. So I will say that u is equals to x and v is equals to 1 plus 2x. Whenever you applying u and u upon v or u into v, make sure to write down the functions separately. So u dash is equals to 1 and v dash is equals to 2. The working formula we have for u upon v is, in the denominator we have v square, and the working formula says v derivative of u minus u derivative of v. We are going to place the values here. So v is what? V is 1 plus 2x, derivative of u dash is 1, minus u is what? U is x, and derivative of v it's 2, divided by v square. So v is what? V is 1 plus 2x and its whole square. Now if we multiply the bracket, so it will be 1 plus 2x minus x into 2, it's 2x, divided by 1 plus 2x whole square. 2x and 2x cancel, so the answer is 1 divided by 1 plus 2x and its whole square. Alright, so that is the first part, that you need to derivate x upon 1 plus 2x and show that it is equals to 1 divided by 1 plus 2x whole square. Now for the next part, we can say that if we derivate the function d by dx of x over 1 plus 2x, so it's equals to 1 divided by 1 plus 2x and its whole square, right? Now again we are going to apply the method of reverse integration, and if I apply integral on both sides, so I can say that the integral part of 1 divided by 1 plus 2x whole square, on the left side these two cancel, and the leftover is x divided by 1 plus 2x. Alright, now the one difference that is left behind, that what is asked in the question and what we have, is that 2 here, right? We are getting 1 basic. So if I write the expression, it's integral of 1 to 4. In the denominator we have 1 plus 2x, and this square is basically on both the numerator and the denominator. So I will write the denominator in this way, and 2 square is what? It's 4. Alright, so if I write in this way, or it's 2 divided by 1 plus 2x whole square, these two are same to write down the expression. Alright, so if I compare that, what I need here, it's 4, and what I have, it's 1. So now we need to multiply 4 on both sides. Alright, so I will multiply 4 on the right side, I will multiply 4 on the left side, and the limits we have, it's 1 and 4. So on the right side now it will be integral of 4 divided by 1 plus 2x whole square, and on the left side it's 4, and now I am going to apply the limits here. So the upper limit we have, it's 4, so now it will be 4 divided by 1 plus 2 4s are 8, upper limit minus lower limit will be 1 divided by 1 plus 2, it's 3. Further I can solve it easily, so it's 4 divided by 9 minus 1 upon 3, and outside the bracket we have 4. We can take LCM, and that is equals to 9. It's 4 minus 3, 3s are 9, so that will be 1 over 9 times 4 leads to 4 over 9. Alright, and on the right side we have integral of 4 divided by 1 plus 2x whole square, and that is your answer. Alright, so such type of questions might be confusion for you, but at the beginning of this reverse integration technique, but once you had solved 3, 4, 5 questions, then you can easily get the concept that how to find the integral of those functions that are multiplying or dividing with the help of their differentiation. Alright. Now you need to write down the solution in your copy, and for this part you have a time of 4 minutes to write it down, and then I will start the next question. So start. Alright, so I hope that all of you have written this solution in your copy, and all of you now have a clear idea how to solve such type of questions, right? So moving on towards the next question, it's question number 12, and with the same strategy of you need to first derivate the function to show that this expression, and once you have derivate the function, then you need to start with the integral process, which I have told you in the last question. Now the last question I have explained you thoroughly, and then I ask you to write it down. For this question, first you need to try it by yourself. First start with the differentiation process, and then start the integral part, and then I will explain you. And for this part you have a time of 5 minutes to complete the solution. So start. Alright, let me start from the differentiation. We have the function 2x over root x plus 1. So I can say that u is equals to 2x and derivative of u is equals to 2. V is equals to x plus 1 with the power 1 upon 2, and V dash is equals to 1 upon 2. Subtract 1 from the power, it's minus 1 upon 2. And if we write in more simplified form, so it's 2 over x plus 1 with the root sign. Alright, and after that we need to place the values in the working formula. In the denominator we have V square, and V is what? V is x plus 1 to the power 1 divided by 2. Alright, in the numerator it's V, that is x plus 1 power 1 upon 2. Derivative of u, it's 2, minus u is 2x. Derivative of V, it's 1 divided by 2 under root x plus 1. Alright, now this 2 and this 2 cancels, so what we have, it's 2 times x plus 1 with the power 1 upon 2 minus x divided by under root x plus 1, and the total fraction divided by x plus 1, 1 upon 2 and 1 upon 2, 1 upon 2 and 2 cancels here. So in the denominator we have x plus 1. Alright, now we need to take LCM in this part. So the LCM here, it's x plus 1, and when you multiply this root with this one, so root a into root a, we know that it's a. Similarly, root x plus 1 times root x plus 1 equals to x plus 1. So now it will be 2 times x plus 1 minus x, and total divide by x plus 1. Alright, so in the numerator we have 2x plus 2 minus x divided by this x plus 1 shift in the denominator, so that will be x plus 1 times x plus 1 with the power 1 upon 2. So in numerator it's x plus 2 divided by, bases are same and they are multiplying, that means we can add the powers here. So 1 plus 1 upon 2 leads to 3 divided by 2. So in the denominator it's x plus 1 to the power 3 divided by 2, and I think that we need to show the same, x plus 2 divided by x plus 1 and 3 upon 2. Yes. So that is the first part of differentiation, that we had shown the left hand side is equals to the right hand side. Alright, after the next one, it says that d by dx of 2x divided by under root of x plus 1 is equals to x plus 2 divided by x plus 1 to the power 3 divided by. With the same approach we need to apply integral on both sides, right? So on my right side I have x plus 2 divided by x plus 1 to the power 3 divided by 2, that is what we are looking for, right? And on my left side integral and differentiation cancels, So the leftover we have 2x divided by under root x plus 1 with the limits that is given in the question is from 0 to 8. Now the important thing, or you can say the easy thing in this question is what is asked in the question, right? And what we have, they are exactly same. It means that there is no need to multiply with any number, because in the last two parts we have multiplied any constant to make the same expression as what we are looking for. But in this question, the expression that what we are looking for and what we have, it is exactly same. So there is no need to multiply with any constant number. Just apply the limits on my left side to find out the final answer. Alright, so the upper limit, it's 8, so it's 2 times of 8 divided by under root 8 plus 1. Upper limit minus lower limit is 0, because 0 in the numerator will make the whole fraction to 0. So now it's 2 8s are 16 divided by 8 plus 1 is 9, which is equals to 16 divided by 3. And on my right side we have integral of x plus 2 divided by x plus 1 to the power 3 divided by 2. Alright, so I hope that all of you had done it, and that is the final answer of your question. And such type of questions appears very often in your past papers, so make sure that you have a clear concept that what strategies we had used to find out the integral by using the strategy of reverse differentiation. Alright class, I hope that it is clear to you. I think that it is quite enough for today class, and what you need to do as a homework, you need to try question number 13 from the same exercise 20.2. Alright, give it a try and verify your answer from the book. Make sure that you are doing it right, and the steps that we had discussed in today's session, you need to apply all those steps in that homework question. Alright, so see you in next class. Take care and Allah Hafiz.